The advent of new technology is changing the way we do business. Stereolithography, along with other state-of-the-art communication and design tools, has enabled Molex to remain on the cutting edge of product design systems. Early in the product development process, a customer is met by a Molex sales representative and a product engineering manager to discuss initial concept details. The first criterion is to determine how the customer intends to use the part and address areas that require the most accuracy and detail. The information is assessed by a product engineer who begins to develop the model on a computer-aided design system, or CAD. Use of this modeling system is an essential step in taking a concept and transforming it into a three-dimensional or 3D solid object. At any point in the design process, direct communication with the customer can be achieved in a number of ways. CAD allows us to transmit 2D and 3D information to and from customers, encouraging their involvement throughout the project. A state-of-the-art process developed at Molex is the Cad Fact System, which allows transmission of information in the CAD database via phone lines to normal fax stations anywhere in the world. The advantage is that it's 100 times cleaner than conventional fax systems because it originates from an electronic database. Additionally, there's CAD conferencing, which allows us to capture images from video cameras and CAD sessions and discuss them in real time with remote locations. This is especially useful in the lab, where models can be examined under the critical eye of a microscope while the images are being viewed in distant locations. A finite element analysis is performed on the newly designed part, a procedure which tests the CAD image as an actual working model and applies stress to measure levels of durability. Meanwhile, pictorials can be simultaneously produced, which again invite the customer to remain involved in the design process. The product engineer then meets with the director of engineering to discuss final details before beginning the stereolithography or 3D printing process. Parameters for the model are established in a separate computer, after which it's sliced, similar to a CAT scan, into layers as thin as 2/1000ths of an inch. The model is then merged and the information is sent to the control computer, which prepares to grow the part. Up to 60 total parts of 11 different designs can be grown at once. Inside the stereolithography tank, or SLA, an elevator platform lowers below the surface of a vat of resin. A helium-cadmium ultraviolet laser then begins to trace the pattern of the model, curing the resin it strikes. Penetration of the laser is precise as it covers the image by producing thousands of microfacets which ultimately become the support for the structure. As the platform is dropped down one minute layer at a time, a wiper blade comes across to level the resin for the laser to cure the next slice. Each layer is attached to the previous one until the entire structure has been created. The finished model, which is not fully solid at this point, is then finished cured in an ultraviolet oven for reinforcement. The model is now ready for customer inspection. One benefit of the design process with stereolithography is that the customer can look at and hold an actual prototype model and determine what areas can be modified or enhanced long before it's to be manufactured. Through the advent of the modeling system, changes are easily made, and solid model variations can be produced in the SLA tank as many times as necessary. Also, larger versions, such as 10 times the normal size, can be produced to make the customer inspection process even easier. During the early stages of stereolithography, the resin available produced a very brittle product. But thanks to advances in this technology, the end result has become as strong as PVC, and in the near future will be as resilient as nylon or polyester. In some cases, Silicon molds are already being formed directly from the models produced in the SLA process. This is quite a dramatic change from conventional product design techniques. In the past, the development of parts was an expensive and lengthy process. To design a prototype, make revisions concurrently, and then machine it could take weeks or even months to complete and cost tens of thousands of dollars. By using stereolithography, depending on the complexity of a design, the same process can be performed in less than a week's time and cost only a few $100s. It's easy to see how this process has changed the evolution of product design and opened a whole new world at Molex. As technology continues to advance and improve this process, in the long run, it will ensure the development of superior products well into the future.